Hi, welcome back to EducateTube.com. My name is Sipsky, your host. Today I'll be showing you how to charge your Alkaline battery using an Alkaline recharger. Last year actually I showed you how to charge these batteries using a solar light. Now that's great only if, for example, if you want to leave it outside and it will charge it for a couple hours and then it will drain away. So it doesn't charge fast enough and long enough for it to sustain for 10 hours of light. So the key is to get a Alkaline recharger like this one. The one I got is called Pure Energy, but you can get any Alkaline recharger. Now they recommend that you use their own version of Alkaline batteries. But what's the point, right? I mean, the point of being able to charge Alkaline batteries is to use any battery. So my advice is to keep it, because they recommend that you use their battery. I would advise you is if you're going to charge other regular Alkaline battery, just make it safe, right? For example, get a metal plate like this one that's fire protective, right? So you put the charger on top of it, so if it does burn, right, at least it's contained within this metal plate. And on top of that, there's a circuit that's built in anyway in these Alkaline battery that's ensuring that it doesn't overheat. On top of that, you want to get an Alkaline battery recharger that's running on a USB wire. Okay, so that means that the current that's running through is very low, so it takes longer to charge these Alkaline battery, but at least it's not gonna overheat to the point where it's gonna explode, because there's a very low current that's running through it anyway, right? So, and on top of that, because it's hooked up to a USB, it's sitting right on my desktop, and I can monitor it as I go. I turn this computer off at night, and so this is also turned off anyway. And since I'm using this computer, and I can actually feel for the the Alkaline battery whether it's overheating or not, like every 2-3 hours. It takes about 5 to 8 hours to recharge these batteries anyway. So I can when I'm doing my computer, I can be monitoring it. If there is a fire, I have a smoke alarm that would tell me that this is burning. Right, so there's a lot of safety features. You always have to monitor this recharger anyway, whether they say it's quite safe. But in general, as a rule, any recharger, recharging a battery or any device should always be monitored, especially lithium battery. Okay. What else? The key to success is, of course, not to drain this lithium battery, this Alkaline battery to zero. You want to keep some charge in this Alkaline battery up to maybe 30%, 30-40%. Then you recharge them again, right? That's the key. And if you do that, you can extend the life on these Alkaline battery for 20-30 time charge. Some claim over 100 times, but I haven't tested that out yet. But I would say at least 20-30 times you can recharge these Alkaline batteries. And now it's not going to be used. Once you charge it, it's not going to be useful in a high drain device like a digital camera, right? It may not have enough juice for that. But however, if you are, you have a LED light like this one here, it's running on AA or double A, or there's some that's actually running on AAA AA battery, and this is only $2. And because it's running on LED light, this is a great device to have, especially during emergency, and using the Alkaline battery to charge them. So again, see, now you have infinite amount of energy using Alkaline battery recharger to charge an LED light. I have two versions of it. This is actually $2, and this one is also $2. And again, both of them are running on AA batteries. 2 or 3 of them put in these flashlight, and it can be used. So that's the application to that. Okay, now I'm going to show you how the voltage and currents are different from battery that is almost dead. Okay, so 34% drained. And then you have one that is almost fully charged. The difference is quite a lot, actually. If you compare the current, right, on the almost drained battery, it's about 0.65 milliamp. Oh, sorry, amp. And then the other one, when it's almost fully charged, is about 1.5 amp. So you can see the difference. And the voltage, when it's nearly drained, is about I believe it's 1.12 or something like that. And then when it's fully, almost fully charged, it's almost 1.2 or 3. All right, I'll show you right now. Okay, so let's now measure the Alkaline batteries that I've been charging now for 2 hours. So I add another hour of recharging. Initially it was 0.3 amp when I measured it across the battery. There was at that given point it was 0.3 amp. Then after 1 hour it was 0.6. Now another hour has passed. Let's see, so this is 2 hours now has been charged. So let's see how much current is now in this that we can measure in this battery. Okay, so it's still it hasn't really changed much. It's still 0.67. Okay. What about this one? Current is running through here. Okay, I think that's about it. No, there isn't. 8.5.7. I have a feeling it's because of this battery that I implement. This is still 0.3 amp. So this battery is pretty much useless. But let's it's staying at the same amp, right, as it was before after 1 hour. So what I'm going to do is I'm going to charge another hour and see what happened without this battery that's causing the current not to flow. I have a feeling this battery actually caused the current to stay as it was before, so I'm going to have to throw this battery away. Okay, so after another hour, so it's been 2 hours now. Let's see how much amp has been added to the battery. It was initially, when it first started, it was 0.3 amp when you measure it, and then after 1 hour I measured it was 0.7, and now after another hour, let's see what it is now. Okay, it's gone up a bit from 0.7 to 0.8. Let's have a look here. Okay, it's 2.87, so not much increased, just slightly. This one, 8. Okay, so just a little bit more. So in conclusion, I would have to say that using a regular alkaline battery to charge on the alkaline recharger, the maximum time you need to put in it is probably 2 hours. It won't increase any more amperage on the battery for some reason. Okay, so I would say 1 hour is sufficient. It will go from 0.3 to 0.6. Another hour will only increase by another 0.1, which becomes 0.8. So in my experiment, it seems to me that the maximum for you to charge any alkaline battery is about 1 hour, maximum 2 hours. It's not going to help. And remember, as long as you can maintain around 0.3, 0.4 amp on each of these AA battery, you can actually power a LED light, no problem. Okay, so just as long as when it's around 0.3 amp, just recharge it for 1 hour. It goes up to 0.6, or for 2 hours it will go up another 0.1, which is 0.7, 0.8, and that's about it. Okay, and on top of that, not all alkaline battery will work. Some will actually leak and even explode if you're not careful. So far what I've noticed is that Sunbeam alkaline battery, this two here, actually does charge well. The Ikea alkaline battery does not, so don't use that. Okay, so it depends. You might want to experiment with each of the batteries. Just measure the amperage on each of the AA battery. If after 1 hour it hasn't increased its amperage, that means that alkaline battery is not gonna continue on to work. Okay.